The subject of the talk is really going to be like sort of understanding the up and coming OpenAI SDK hasn't been released yet. And my job is to basically give you guys enough information to really understand it and also attack it based on any unsound decisions that I made when this project was made. And hopefully it leads to a better SDK overall. And basically, the OpenAI Ruby SDK is coming out sometime this week or the next. And that'll be pretty exciting for me personally because I work on this project, but also I'm a big open source programmer. I really like to work on dev tooling, and all of my projects are mostly CLI, Vim related. But I got the chance to work on the Ruby SDK for OpenAI and among other companies, right? And that's very exciting, and also for my employers as well. I work at Stainless API, and what we do is we take your OpenAPI specification, which is a big JSON that's telling us like what your server-side API looks like, and we have a printer that turns it into code. And it's exciting for us because we're shipping the Ruby printer right now, and I'm the owner of the Ruby printer. So why is OpenAI even paying us? There's already community SDKs in terms of things that's really popular and widely used. And from the onset, if you just look at our examples in README, it actually pretty much just looks like the community example. But there are some differences that you're going to see are going to pop up later. First of all, let's just go into slightly the anatomy of the community SDK. It's a very thin wrapper of, this is an excerpt from the community SDK. You get your OpenAI server, you have your HTTP transport layer that handles for you. It encodes and decodes JSON, and you do whatever the fun things you want to do with it. And that's well and good. But what is an SDK for, right? There's two audiences. One is you, the programmer, and other one is your machine, your tooling. And because OpenAI gives us a really big JSON in terms of the amount of knowledge, we have a lot more than almost anybody else. Therefore, we have really good documentation, and because knowledge is power, and we have really good editor support. If you're working in Ruby, you're gonna know that editor support, in particular for libraries, is pretty tricky. Over here is an example that we have where if you use Solograph, you actually get generic support. So over here, you get a stream, you get back the stream is of different chunks, and on each chunk, there's a choice. You can flat map over that choice. And your VS Code, actually, if you have Solograph installed, knows that you get an array of choices at the end of this. And to take it even step even further, if you do choices.first, and you get sort of the properties on each of the choices, therefore you get a really nice and ergonomic interface that you can use to make you more productive, essentially. And what it also does is it lends itself well to static analysis. There is actually a bug in the previous cases. I made a typo. It says role user, not rule user. And that wasn't caught until we turned on sorbet support, and which our gem also ships with sorbet. If you don't really know what sorbet is, it's this sort of like type checker for Ruby that is fairly sort of popular for enterprise areas. And over here, the second thing is actually kind of hard to catch. If you have a list of choices, the first choice might not be there because the list might be empty. Therefore, you need to use the nil navigator to make sure, like, hey, if it's nil, let's just propagate the nil. We also ship with complete RBS support. And what that does is like the Ruby 3.0 ship with the new type declaration syntax. It's not being widely used right now, but at some point, potentially it might be. And we're very happy that it's in place because why not? Even though this one has currently less tooling coverage. And in order to achieve sort of this nice level of editor support, we kind of need to basically build our own class abstraction on top of just the data shapes, right? Because all of Ruby's tooling uses Reads classes. And the issue with abstractions is that a lot of times they're anti-helpful because they're like overly abstracted. They have impedance mismatch with their code. You might not be able to easily convert from the abstraction that you want into like, into the one that you need. And a lot of, like, I'm a programmer. I think a lot of programmers echo this opinion. Like, my abstractions are, like, the ones I know. It has all of the flaws that I'm familiar with. And other people's abstractions are, like, terrible because they're meant to be so generic that, like, they just hit you in unexpected ways. And we're going to talk about the abstractions that is in the current SDK. There's two main ones. The first one is the primary abstraction, which is the we call it base model, but what it is are like the data containers of the Ruby SDK. And these ones, basically, there's dual purpose. The single purpose, well, actually, purposes. First purpose is like human readable. So you got to be able to read this and easily interpret what it is without even having an editor help you. And second one is for the toolings to be able to interpret it really well. And the third one is for the SDK internals to be able to interpret it and make choices for you. And the second one is, well, this one is actually from Anthropic's SDK. They just released a couple hours ago. I'm using them as an example because they have really good unions in terms of the response types. So what a union is that when the server gives you back a shape, that could be a number of different things. And in order to work with these number of different things, it'd be nice to have an ergonomic interface to deal with them. And therefore, well, I'll come back to them really quickly. But in the first one, it's even though we have this data wrapper that we have that's data containers, they're class-like, we offer a really easy way to deconstruct them as if they are just any regular sort of standard library hash, standard library like arrays, and standard library sort of like any of the data types you would expect. And this is sort of the Ruby recently introduced, I think, 2.7 pattern matching syntax. And you get this recursive consistency in terms of you're able to pull out, for example, the first stream has some properties called choices. And the choices, the first choice, I can pull out the first choice, get the text, and get the finished reason, right? And this is a really nice way for people who maybe use Vim and don't really care about editor support for you to just be able to like, give me the data. I just want to know, I just only care about data shape. I don't care about the classes, and I don't care about sort of auto-completion. I don't need them anyways. But of course, if you do want auto-completion, and if you do want good editor support, there is a nominal sort of case where if you actually use Ruby like a more language that has like more sort of like classes and stuff, and your language, if your language server supports it, like sorbet will actually do type narrowing on each of these sort of cases in a switch statement, and you're able to propagate the types down to the rest of your code, and they would be give you static analysis all the way through your SDK. And we ship this basically without an actual any sorbet runtime dependencies. It's only based on sort of like type annotations we ship. So it's almost like TypeScript shipping like d.ts to your folks. And that's a convenience in that you're not forced to depend on a really heavy runtime or like any runtime. By heavy, I don't necessarily mean like the compute, but just in terms of like maybe you don't want the mental overhead. And to combine them, we also, this is the case where, the same case as previously, where if you just care about the shape, you don't care about editor support, you also can recursively pull out all of the contents, and you're able to work with them as if you just get like raw hashes back. And why not both, right? This is actually how we write our tests, which is to actually reuse the pattern matching syntax, because Ruby has a no pattern match here. So for a lot of our tests, we just assert that for each of the switch statements, we recursively match against the data type they're supposed to be. And if there's some serialization error, which is what all the SDK cares about in terms of most tests, you're going to know if they fail. And right, so circling back to execution model, right? The community SDK is very thin. It does what it's really great. It does whatever you want it to do. Just gives you back the raw data. But what we do is we add a normalization step when you get the data back. And we do the reverse normalization step when you want to turn those like rich classes into data to send over the wire. And one more thing that we also do is canonicalization, which is that if you have a type, because our SDK has this DSL knowledge of the schema, and you say if you have a type that's or get back a string, it might be like of a date type, of a date shape, and we automatically wrap that with a date type for you, so you don't have to do all of those cumbersome typing and wrapping. All right, so that's the anatomy of the regular SDK, right? Like, what about the AI stuff? Where's the specialization in this? It comes in mostly in the streaming HTTP client itself. So we do use a sender library net HTTP sort of client. And that client is not sort of known for its ergonomics. Therefore, we add a lot of convenience features on top of it. So for example, in AI use cases, you often want to have really big inputs, and you can just store them on a file system, and they do not have to be all buffered into memory at the same time. And we automatically open the file and close the file for you and handle retry and redirects and everything else that you would expect a good SDK to handle for you. And of course, if you already have data, we also take like string IO, and you can, have it your way. One more thing. So previously, I showed an example that was very quickly glanced over, which is a stream example. Over here, one thing is that all of the underlying transport are actually a series of enumerables. So therefore, you can work with them and transform them as if they're an array. And you can do lazy transformations. Therefore, because AI is kind of slow at giving you all of the data right away, you have very low latency if you just do stream.lazy, and you can get back and process each of the chunks right away. And at the end of the stream, as long as you call a terminal operation like .each or .to_a or any of the things that that consume the stream, you actually do not need to worry about sort of cleaning up that underlying HTTP connection. Even though we do connection pooling for you, all of this is sort of like clean up behind the scenes. So your application code does not need to worry about like if this thing is from like across the web. All you need to care about is, oh, cool, I have a stream of data, and that's that's something I'm quite proud of. And how it's actually implemented is actually like a stream of data that goes through each successful transformations. First, the server sent events, for example, you reframe the responses you get back from each chunk into lines, and then you decode them into bigger assemble them into bigger chunks of events. And finally, you have sort of like a state machine that parses every single piece and says like, oh, if I get an error event, I'm going to throw an error, but if I do just get a data event, I am going to yield it to your actual application code. And how it's actually done is something that I don't really have time to talk about because I only have 10 minutes. But it uses really neat trick that basically chains enumerators together. Enumerators in Ruby actually have a rewind method, which is, I don't know if it's super well known, but we were able to smuggle all of these sort of successive transformations and chain the cleanup back using the rewind mechanism. So if you rewind and then take the next item, we actually clean up the stream for you, which is actually like why you don't have to worry about it. And this is purely an implementation detail that I stole from Rust in terms of like their fused iterators, which, nice language. And that concludes my very short presentation. I hope you guys will have something to think about, and give me a holler when OpenAI Ruby goes out and in GitHub issues, and let me know what I can do better for you guys. Thank you so much.